Hello and welcome to our lesson on statistical graphs. Hopefully this lesson will be a nice review for you. What we talked about in topic 1 was different ways to collect statistical data. We said data could be collected through a variety of different types of surveys. We could also experiment in a situation, and there are other situations where an observational study was more appropriate. Now, once all of the information is collected, there are different ways to organize and analyze that data. So today we're going to talk about some of the typical ways the data is organized. So we're going to start by looking at what we call a frequency distribution. That's a fancy name for a two-column table, okay? So a two-column table. And in this two-column table, you're organizing and kind of summarizing the data. Column 1 shows the observed values. So if you conducted a survey, what were the answers to the survey? What did people respond to the survey? Like if you surveyed on how many kids, a couple had. And, people said 0 kids, 1 kid, 2 kids, 3 kids, whatever. All those results, the things that they said that they answered, would go in the observed values. What were the observed answers from your survey or your experiment or your observational study? And then column 2 shows the frequency of those observed values. That is, if 0 was an option for how many kids were in your household, how many people said 0, or how many people said 1, or how many people said 2, and so on. So it's what were the answers and how many times did those answers occur. Okay, so when you're making a frequency distribution, there are a couple of rules. If, for example, I was making a frequency distribution based off of, let's say, quiz scores, there's going to be quiz scores ranging anywhere from 0 to 100%. I don't know that I want to make a two-column table that starts at 0 and then goes all the way to 100. That's a lot of different observed values to make in a list, and it doesn't really help us organize the data. So we might want to group the numbers. So maybe we put like the students who got from 90 to 100 in a group, and then we put 79 to 79 to 89 in a groups, and so on. So you're going to group these things to try to make it a more organized graph for your data, or two-column table for your data. So when we group the data, we call the groups in our frequency distribution classes. Okay, so we have the first class of quiz scores could be from 90 to 100, for instance. And again, this is to condense the distribution so that we're not looking at a table that has 100 different quiz scores in it. And then when you group the data into classes, there are a couple of rules for the groupings. Okay? The classes, again, that's another name for the groups, they have to be equal in size. So if you put 10 numbers or 10 quiz scores in one group, there should be 10 in the next group, 10 in the next group. So you want all of the groups to be the same size, and we call that size of our class, of our group, the width of the class or the group. Okay, and then the classes, the groups, they shouldn't overlap. So there shouldn't be two different groups where you could put one quiz score, for instance. Okay, and then this last one is just a suggestion, but in general, we want for our frequency distribution to contain, I don't know, anywhere from 1 to 12 classes. Okay, we don't really want to go beyond 12, and obviously less than 1 means you don't have any data. Okay, so 1 to 12 is pretty standard. Even 1 seems a little bit sparse, but I guess it could happen. Okay, so here's an example. We have 23 students that were given a quiz on U.S. presidents. I don't know about you, but I failed that quiz. I don't know how far back I can remember. Anyway, the data shows their scores. We are asked to construct a frequency distribution. Again, that's fancy for make a two-column table. And this one says to make a class width of 7. So a class width of 7, this means that each of the groups should contain 7 numbers. Okay, each group should contain 7 numbers. 7 7 observed values, 7 different quiz scores in this case, okay? So let's start with our lowest number, right? We don't need to include anything in this table that isn't in our actual observed values. So the lowest number, the lowest quiz score, let's see, is it 55? I think so. Okay, so we're going to start our observed value list with a first class that starts at 55, and then if we want 7 numbers or 7 observed values to be in that class or in that group, then 55, 56, 57, 58, 59, 60, and 61. 1, 2, 3, 4, 5, 6, 7. So this is going to end at 61. So there's 7 values. So this is a little tricky because if you look at the difference between 55 and 61, it really looks like a difference of 6, but it's because we're counting one of the endpoints here that we actually have a difference of 7. So you can see it, we listed it out, 55 to 61 is 7 different observed values. Okay, but the difference between the two of them is 6. So we want that to happen every single time. And then again, we don't want any overlap. So if the first class ends at 61, then the next class should start at 62. And again, we want the same number of values. So 62, 63, 64, 65, 66, 67, 68 is going to give us 7 different values. And again, that shows us a difference of 6. Okay, so this one ends at 68, the next one's going to pick up at 69, and then if we add 6 to that, we're going to get to 75, and then we'll start the next class at 76, add 6 to that, and we get to 82. And then we pick up here at 83, add 6 to that, and we get to 89. And then how far do we have to go here? So how far we have to go depends on our biggest number. We need to make sure we have a class that can hold our highest quiz score here. So it looks like the highest score is a 92. Yeah, so a 92. And so I think one more class will do it. So this one left off at 89, the next one's going to start at 90. And even though our highest score is 92, we need these classes to be the same size. So we are going to go all the way to 96. Okay? So now we have our classes established. We have our groups that we're going to put these quiz scores into. Each of them has the same width. Each of these classes has 7 different observed values in it. Alright, so now we just got to figure out the frequency. That is, how many quiz scores are in each of these groups or classes. So I'm going to use my highlighter now. I'm going to highlight all the ones that are 55 to 60. So 55 to 60, that would be 56, 58, 55, and we're going to 61, sorry. So let's count the 61. And I believe that's it. Okay, so we have 4 different observed values. 4 different quiz scores, there's a frequency of 4 in that group. So 4 quiz scores that are in the 55 to 61 range. Alright, so now we're looking for quiz scores that go from 62 to 68. So 62 to 68. Oops, I just see I left off a 59 over here. See how easy it is to make miss these little guys? That's why I was trying to use the highlighter. So this should be 5. Okay, back to green. Okay, we're 62 to 68. This guy here, this guy here. I think that's it. If I miss one, I'll catch it later. So that's going to be 4 quizzes that are in the 62 to 68 range. And now we're going to go 69 to 75. 69 to 75. And I think that covers it. So we've got 1, 2, 3, 4, 5, 6 there in the yellow. So 6 in that one. How about 76 to 82? 76 to 82. 76 to 82. Looks like those guys. So that's a total of 4 that I highlighted there. And then 83 to 89. I'm running out of colors here. Ooh, orange. 83 to 89. It's going to include those two. And then lastly, 90 to 96 is the only two that I haven't highlighted yet. So we've got two there again. Now, just so I can double check, I'm pretty sure I counted for everything, but I'm going to go ahead and add this list up together here. So I put 5, and then 4, and then 6, and then 4, then 2, and then 2. Oops. And goodness, guys. All together, that is the 23 quiz scores that I said I was given, right? 23 quiz scores. Okay, so everyone's placed, didn't miss anybody out. That is what our frequency distribution looks like. Now, the point, again, is to try to organize the data, and this kind of shows us, we have definitely more lower quiz scores than we have higher quiz scores. We have a higher frequency on this end of the distribution than we do on this end. And we can also see where most of our students landed. Most of them landed in the 69 to 75 range. Okay, so this is a good way to get a snapshot of what's happening with these quizzes, is to put them in what we call a frequency distribution. And I don't know that this term will come up, but we would call this class right here the modal class. Mode is something we're going to talk about, I think, in the next topic, but it's got the most occurring values, or the highest frequency, so we would call it the modal class. It has the most observed values, or not, the other observed values are the same. It has the highest frequency is what I'm trying to say. Okay. Alright, so that's a frequency distribution. I think that's pretty straightforward. And then the rest of these, again, should be good review. The next one we're going to look at is the circle graph. Sometimes you call this a pie chart. Okay, you should be able to make a circle graph, but since we're in an online format here, it's probably going to be more important that you understand the workings of the circle graph. But if we're going to construct one, then we have to know the percentage that each part in our frequency distribution, in this case, right, the percentage that each part of the data represents, and we can find that percentage by dividing by our total. Okay, and then once we know the percentages, we're just going to create sections of the circle that represent those percentages. And it doesn't have to be perfect, but we do want it to look, pretty accurate. Okay, so we've got 300 people. They were asked which of the following colors were their favorite. Choices were red, blue, yellow, green, orange, or none of these. And we're going to try to construct a circle graph that represents the appropriate percentages of the data. So again, 300 total. If 78 people said red was their favorite color, then to get the percent, we have to take 78 and divide it by 300. So 78 divided by 300 is 0.26. And 0.26, remember, if we multiply by 100, we can make that a percent. So if we just multiply by 100, we're looking at 26%. Okay, so 26%. And then 12 people said blue. So again, we're going to divide that by our total, which was 300. And 12 divided by 300 is 0.04. So 0.04. And then if we multiply by 100, oops, let's not do that there. If we multiply by 100, we can see that that is 4%. Okay. And then 96 people said yellow, which is surprising, more yellow than blue. But again, we'll divide that by 300. So 96, let's do this over here. 96 divided by 300 is going to be 0.32 times 100 is going to give us 32%. And then 54 over 300. Change this to this tiny little keyboard. I'm trying to use my pencil. Okay, is 18%. So 0.18 or 18%. And then 42 people said orange. So 42 here. So 14. And then lastly, 18 people said none of these were their favorite color. So 18 is going to be, I can type here, 6%. 0.06, which is 6%. Okay, and if we wanted to double check, you could put all those percents add all those percents in the calculator, and we should get a total of 100%. Okay, you just trust me. I'm pretty sure I didn't screw that one up. Okay, so now we have to try to make a circle graph that represents each of the percentages that we have here. Now, some percentages are easy to create, like 50%, right? Half of the circle, that'd be pretty easy. Or 25%, a quarter of the circle would be pretty easy. So if I had, 25s or 50s, I would definitely start with those. And actually, I see 50 in here. I don't know if you're seeing that, but 32 and 18 is 50. So I'm going to make half of my circle include the yellow and the green there. So I'm going to cut this in half. I'm going to try. It's not too bad. Okay, so half of that circle now is going to be broken into 32% and 18% for yellow and green. So 32 and 18 maybe is going to look something, let me make a center here, maybe is going to look something like this. It doesn't have to be perfect, but something representative. So let's make this the yellow 32%. And let's make this the green 18%. Okay, so I've taken care of this and this. And now, let's see, 26%, that's pretty close to 25%. That's pretty close to a quarter of the circle. So let's just go ahead and make that a quarter. So let's put the red 26% here. And now we've got one little section to cut into a 4, a 6, and a 14. So let's just kind of cut it. No, let me do that again. Maybe something like that. Okay, again, it doesn't have to be perfect. It just should be pretty representative. So we're going to squeeze in, this is the smallest section, so that's going to be our blue at 4%. And if you can't write it in there, it's okay to write it out. So blue is 4%. This guy is our 6%, which was none. So none, 6%. And then lastly, we had the 14%, which was orange. And I think I can fit that in here. So orange, 14%. Okay, so there it is. There's a circle graph. So you should be able to create one, but more importantly, you should be able to understand the workings, so understand how the percentages represent the total, and so on. And then, if I give you a circle graph, be able to answer some questions based off the information. For example, let's say 650 people were surveyed about their favorite beverage, and the following results are shown in the table. It says 45% preferred water, 42% preferred soda, 8% preferred juice, and then there's 5% who said something else. Okay, so it says how many people preferred water. Now you might want to say the answer is, well, water's 45%, so 45%. But it's not asking what percentage of people preferred water, it's saying how many actual people. So we need to figure out 45% of the 650 people that were in this survey. So how do we figure out 45% of 650 is the question. Okay, I actually think that Desmos does this. I should have looked, but I think it does. Let me see. If I did 45, I think on the keyboard there's a percent in here. Yeah, it's with the exclamation point. So percent, yeah, see it does. If I go to my normal looking keyboard here and hit the percent, it automatically says 45% of, and then we can type in 650, and it's going to give us 292.5. 292.5. Now technically, what's the math that's happening there? When we say 45% of 650, how are we getting to that 292.5? So 45% as a decimal is 0.45, and usually that word of is telling us to multiply. If we multiplied by 650, then there's our 292.5. So just, the calculator does it, but just so you know the math that is behind this, this is 0.45 times 650 to get that 292.5. Now, let's go back to the answer of 292.5. Obviously, 0.5 of a person doesn't make sense. Just because someone's short doesn't mean they don't count as a whole person, okay? That would be discriminatory. So we want to round this. Since it's at 0.5, it doesn't really matter if we round up or round down. So I'm just going to choose to round up. I'm going to say 293 people preferred water. Okay, so next it says how many people preferred something other than soda, water, or juice. So the other, that was 5%. So now I need to know what is 5% of 650. So I'm going to go back to my calculator, change that to a 5%, and it's 32.5. 32.5, and again, 0.5 of a person's not going to make sense, but the 0.5, we can round either way. I chose to round up on the previous. On this one, I'm going to choose to round down, because if I round up both times, I'm going to end up with more than 650 people. So you only have to worry about that happening when you are like right in the middle, and you have the choice of rounding up or rounding down. If it happens like what's happening here, you know, if we round one up, then round the next one down so that it keeps the balance. So I'm going to round this one down to 32 people. Okay, and then how many people preferred soda or juice? Remember what or means. That means we want to unite those two groups. That means we can add them together. So we're going to add those together. Soda or juice would be putting these guys together. That's 50%. 42 and 8. 42% plus 8% is 50%. And we want 50% of the 650 people total. So 50%, come on, is 325. And that one was exact, so no rounding. And again, we could add up 293, 32, and 325, and that's going to take us back to the 650 total. Okay? Not so bad. So you should be able to make a circle graph. You should be able to read, interpret a circle graph, and then again understand the percentages. All right, next one we're going to call a histogram. Histogram is fancy for a bar graph. There actually is a distinction between histograms and bar graphs. Histograms are generally involving only numeric things. Bar graphs, we can put non-numeric things in there. Like you can make a bar graph for, I don't know, let's say you were sorting shapes and you had like triangles, you had squares, you had circles, you had rectangles, and you could say, oh, there's this many of these and this many of these, whatever. So these are sort of the same concept where you are making bars, but a bar graph is generally for non-numeric things, and a histogram is specifically numeric. And that's what we're going to be dealing with here, numeric things. So in either case, when we're making our bar graph or histogram, the observed values, whether numbers or not, they get plotted along the horizontal axis. So the horizontal axis, which is like our x-axis, okay? And then the frequencies are plotted on our vertical axis, which is like our y-axis. Let's make this make grammatical sense here. They're plotted horizontally. That's the x. And then frequencies are plotted vertically. That's like our y-axis. Okay? Now the horizontal and vertical axes don't have to match. So like I can go by 10s here if I wanted to, and I could go by 2s here if I wanted to. They do not have to match. It's what's ever going to be convenient for the information that I'm looking at. So the axes do not need to match. And now the horizontal axis, again, that's our x-axis here, that can be labeled with single observed values. Okay, so here, for example, 64, 65, 66, I can put those singly along my axis, or if I have a group, and I'm going to show you this when we get to the next type of graph, we have to find the midpoint of the group. So on an axis, I don't want to put two different numbers, so I need one number to represent the group. So we're either going to put individual values if that's what we're given. Or if we have groups, classes, we're going to put the midpoint of that group or class. Okay? And then our horizontal axis, again, that's this one, does not have to start at 0. It can start with wherever our data starts. But our vertical axis does have to start at 0, otherwise it could distort the picture. So only the vertical scale must start at 0. Alright, so we're going to try to make a histogram here. And we've got this table. It's the heights of students in a class, and I'm assuming that these are heights in inches, and how many students have that height. So we have 2 students that are 64 inches tall, 6 that are 65, 10 that are 68, and so on. So let's make a graph here. So along the bottom, we're going to put height in inches, and then along the vertical axis, we're going to put number of students. Okay, so the heights, again, we're starting at 64. So 64, 65, 6, 7, 8, 9, 70, 71, 72 as high as we go, so that fits perfectly. And now our vertical axis has to start at 0, so we want this to be a 0 here. And then we want to spread the data out as much as we can, but we also have to make sure we fit everything, right? So the highest number we have is 10, so I think it would be reasonable to go 2, 4, 6, 8, and 10. If we go by 2s, we could fit everything in there, and we've spread it out as much as we possibly can. Alright, so now it's making the bar graph. You've got options when you make your bars. You can make it left-centered, right-centered, or left justified, right justified, or centered. So for example, there are 2 students that were 64 inches tall. So to represent the 2 students that are 64 inches tall, I can go this way, or I can start this way, or I can go centered. And that's the way I prefer, because when I justify it one way or the other, left or right, I always get confused on which number goes with the bar. So you have the option of starting left, starting right, or centering over the number. That's the one I prefer, but it's really up to you. And you also have the option of connecting or not connecting the bars. I like to connect them just because it's easier to draw one, because one side of it's already started, but you don't have to. So again, for example, I could do a skinny one here, maybe not skinny enough, for 2 students in 64, and then there were 6 here, so I could separate those like so, or I could make them touch, so 2 students here, and then I could just build this one up and say 6 students here. So you have options there. And then if you really want to be thorough, we can put a 2 here and a 6 here just to make sure that that's the number that we wanted, so it's just really clear. Okay, so I'm going to keep building. 66, that was 7 students, so now I can just build up a little from there. And then 9 students, so 7, 9 students, let me go up to 9. And then 10 students were 68 inches tall. And you can see I'm getting a little sloppy here. And then we got 6 students were 69 inches tall. And then 3 were 70 inches tall. Nobody in the 71, and then 2 were 72. Only 2 students were 6 feet tall. Okay, so there's a bar graph. So again, this is just a way to organize the data. This is another visual for us. I mean, we can see it here, but it's also clear here where most of our students are in terms of height, so that we have most students, you know, in the 66, 67, 68 inch height. Fewer students are really short, and fewer students are really tall. Why did I make the... I didn't notice my 2 was a little low over here. Just caught it. Now that's terrible. Gosh, guys, why are you letting me make these mistakes? If we were in class, someone would have been like, miss? Okay, there we go. All right, so there's a bar graph, and again, you should be able to make one, but you should also be able to read it. So looking at, if I didn't give you the frequency distribution, right, that's what we have over there, so I'm going to hide that. If I just gave you the graph, you should be able to answer questions like, what's the most common height amongst these students? And you would say 68 inches. Or I could say, like, how many students were less than 66 inches tall? And you would count the 6 and 2 and say, oh, 8 students. Something like that. So you should be able to read a histogram as well. Okay? The last one we're going to look at is called the frequency polygon. This is fancy talk for a line graph. Okay? A line graph where instead of making bars, we're going to plot points and connect them with segments. So we follow basically the same rules as the histogram, but we're going to label points instead of drawing bars, and then we want to connect the points with segments. We want to make sure they're straight segments there connecting the points. And then we don't want our line graph to be floating, so we're going to make sure that we start and stop at 0. Start and stop at 0. Okay, so basically the same rules though, where observed values go on the bottom, frequencies go vertically. So again, it's the same information that we had in the previous graph, except what you'll notice, what you'll notice here is that our heights are grouped into classes. Okay, so this is still going to be heights down here. So we're going to put height in inches, and this is still going to be number of students. But now we have them in groups, and when you're labeling an axis, you don't want to put two numbers on one little tick mark. So for example, if I was going to make a little mark here, I don't want to put 64 to 65, two numbers on one mark, okay, one tick mark. So what I need is one number that represents the group of numbers. So one number to represent the group. If you had to pick one number to represent 64 and 65, what would you pick? Well, I would pick the number that is right in the middle, and that's what the rule is for making your or labeling your axis when you're given a group. So we want the midpoint of the group. Now I can see that 64.5 is right in the middle, but technically if you wanted to find the midpoint, you're going to add the two numbers, so 64 and 65, and divide by 2. And that's going to give you 64.5. So 64.5 is the midpoint there. So what we want is, let's just make another column here. We want to use midpoints. So the midpoint for each of these, and we can see the middle of each of these, but if you couldn't see it, if it was a larger group of number, like if you went from, I don't know, 102 to 157, I don't know, maybe you can see it, but you would just add those two numbers and divide by 2. Okay, so here 64 plus 65 divided by 2 is 64.5. This is going to be 66.5. This is 68.5, 70.5, and then 72.5. So we're going to use those midpoints because they will represent that group. So I only have 5 of them to plot, which means I can spread this out a little more. So I'm going to go 1 here, 3, 4, and 5. And then I'm going to take this out a little further. Alright, so I'm going to put my 64.5, and then what was it? 66.5, 68.5, 70.5, and 72.5. Okay, now on my vertical axis I have to get all the way up to 17, so I don't think going by 2s is going to work. And again, I want to make sure I get all my information in there, so I got to get to 17, but I also want to spread it out as much as possible. So let's see, if I did 3, 6, 9, 12, 15, nope, didn't fit. So 2s, again, not going to fit. 3's not going to fit, so let me try 4s. 4, 8, 12, 16, 20. Yeah, I think that'll work. So this is 4, 8, 12, 16, 20. Okay, so now we're set. Now we're going to make points instead of drawing bars. So 64.5, that's our first group. There are 8 students in that group. So 64.5, I'm going to go up from there to 8 and make a point. And again, I'm going to go ahead and label it. And the next group, which is represented by 66.5, there are 16 students. So I'm going to make a point there at 16. And the next group, represented by 68.5, has 17 students. So I'm going to go a little higher and put a 17. And then the next group, represented by 70.5, has 3 students. Put a 3 there. And then the last group has 2 students. And put a 2 there. So now I want to connect these with segments. So if you had a straight edge, that'd be good, right? I have a little cheat tool. So segment there. Segment there, segment there. Oops, let me try that last one again. Okay, that's close enough. Now, the last piece to a frequency polygon to line graph here is that we don't want it to be floating. So we're going to take the endpoints and then drop them down to the axis. So I'm going to make another segment that makes this thing start at 0. And then I'm going to do another one here to make it stop at 0. So we have, let's make sure we start at 0. Oops, turn that off. Start at 0, stop at 0. So whatever your endpoints are, let's just take them down to 0 at the next or the previous x values, okay, on the x-axis. And there it is. And again, you should be able to read one of these things. So if I hadn't given you the frequency distribution, if I had just given you this graph and I said, you know, which class has the highest frequency, you say, well, 68.5 has 17 students in it, or were there more students, you know, above 68.5 or below, and you would say below because there are 16 and 8, which is definitely more than 3 and 2, or questions like that. So you should be able to read and understand what's happening in any of these types of graphs. Okay, that's it for today. Work through those practice problems, and if you need any help, then just reach out. All right, guys.